coffee cup. All right, so what we're doing here is we're looking at the distance between each point and 0. So what we're really doing is the absolute value. Absolute value is all about the distance. So if we look at A, which is this one here, chunky marker, holy cow, this one here. How far is this point from the 0, which is here? It's 3. The absolute value of -3 is 3. That's what it's asking about here. So how about for B? How far is it from 0? 5. How about C, which is over here? It's 3. And D, super close, careful how you say it. 1.5 or 1.5. Not 1/2. So just be careful. That and makes a big difference, surprisingly. E, how far is this one from 0? Uh-huh, 2.5. It is 2.5 steps from 0. You know, I don't care if you put it as 2.5 or 2 and the fraction. How about F? How far is F from 0? It's 0.81 from 0. Doesn't matter if it's decimal, doesn't matter if things are going on, it's just how far. What is the distance? Distance is always positive. So it's an absolute value. Okay? Today we're going to move in a different direction. And we are going to be looking at switching around forms. Because we talked a lot about our forms of lines in the last chapter. We talked a lot about the different forms when it was in standard form, when it was slope-intercept form, but we never changed really from form to form. So that's what we're going to do. We are going to switch into slope-intercept form today. Identify the slope and identify the y-intercept. So when we say slope-intercept form, what does slope-intercept form look like? Boom, y equals mx plus b. So what we're really doing is we're going to solve and get y by itself. I want y by himself. So it's just like solving, it's just going to look a little different. So on this guy, 12x minus 4y equals 24, I want to get y by himself. I want him by himself. So what do I need to move to get y by himself?
12x.
The 12x. How are we going to move that 12x? Add, subtract, multiply, divide.
Subtract 12x.
Yep. Minus 12x from this side, and we're going to minus 12x from this side. We're going to be left with minus 4y. Can I combine the 24 and the 12x into one thing? So I'm going to put them next to each other. We generally like to have our x's in front of the just numbers, so I'm going to flip their spots. We're going to have minus 12x plus 24. We want to have the x's on the left-hand side so that we're mx plus b. I don't know what is going on with all these little half coughs I'm doing. This cough will not let go of me. I've had this cough for like 3 weeks now. It's driving me nuts. Questions on this step? Because sometimes it feels weird when we change what spot they're in. Okay. I want y by himself. How do I get y by himself? We're not going to plus y. I want the y to stay. So I want y to stay here. What do I need to leave? What is outside my y? The -4. What operation is going on between the -4 and the y? Multiplication. How do we undo it? Division. So we're going to divide by -4. Divide by -4. Divide by -4 to all the pieces. These guys are going to cancel out, leaving us with just y equals, and we're going to do -12 divided by -4, which is 3x. 24 divided by -4 gives us -6. So, what is our slope? Three. The slope is the m, and in this case, it's 3. What is our y-intercept? -6. It's always going to be the b. So our y-intercept is the b, and in this particular case, it's this -6 right here. Questions on that first one? Because this is what we're going to be doing today. We're going to do the same thing on this side. I want to get y by himself. So what do we need to do to get y by himself? Minus the 3x on both sides. That's going to leave me with 8y equals -3x plus 16. I want that x in front, so we're just going to squish them in there. Then what are we going to do? Divide by 8. To all the pieces. So we're going to be left with y equals, does -3 over 8 simplify at all? So minus, does it? 3 and 8 don't have any common factors other than 1. And dividing by 1 doesn't change anything, so it doesn't really help. How about 16 over 8? 2. I do recommend leaving these in fraction form. Don't switch them over to decimals in slope-intercept form. So then let's answer the questions we were asked. What is our slope? Yeah, our slope, that m, is -3 over 8. Remember, that's our rise over run. What's our y-intercept? Our y-intercept is that b, and that is 2. That would be where we would start when we were graphing these. Okay. We're going to do a couple more just like this, and then we're going to do a story problem. All right. We're going to switch this into slope-intercept form. What do we need to do to get this one into slope-intercept form? Minus x on both sides is an excellent place to start. That's going to give us minus y equals minus x. You can put the plus 0 if it helps you. Totally fine. You do not need to. What do we do next? By -1. And you can either multiply by -1 or you can divide by -1. It means the same thing. So we're going to get that y equals x. What is our slope? Not 0. Remember, it's mx. What is the invisible number that's multiplied in front of stuff? 1. What is our y-intercept? That one's 0. So when we're looking at things being multiplied, if it's not written there, it's 1. Things being added or subtracted, if it's not written there, it's 0. One more like this before we go on to the next kind of piece of this, which I think didn't actually copy over on my slideshow, which is fun, but that's okay. Yes, dear. Yes, if there's nothing written there, I could write a 1 in front of this x and I haven't changed it. 1 times x is just 1. Same thing with dividing. Multiplying and dividing, it's 1. Adding and subtracting, it's 0. It's called the identity. The multiplicative identity. Or the additive identity. All right, last one like this. What are we going to do to get y by itself? Not just 8. Minus 8x. Minus 8x. And we have our minus 5y equals minus 8x plus 15. We're going to divide by -5. Divide by -5. Divide by -5. So our y is going to equal, what is -8 over -5? Going to simplify down to. What's the only thing that simplifies there? When we have a negative over a negative? It's just going to be positive. Yeah. We're going to have positive 8 over 5. X. 15 over -5? -3. So our slope is what? 8 over 5. And our y-intercept? -3. We're going to do a story problem like this. It's a bit of a stretch, but it's a thing. So we've got this equation. The equation given can be used to estimate shoe sales in Europe, where X is the number of years after 2010 and Y is the revenue in millions. We're going to solve the equation into slope-intercept form, identify slope and intercept, and put them into context. So we're going to, first things first, put it into slope-intercept form and identify slope and y-intercept. Those are the two things we've been doing. The paragraph doesn't make any difference when we're just solving it for y. So it's longer, but it's not any different. We're going to put this into slope-intercept form. What do we need to do to get the y by himself? So we're going to minus 3,246x from both sides. 246x. And we're going to get minus 2y equals minus that 3,246x minus 152,722. That's a comma, not a decimal. We're going to divide by -2. And this is one of those times when you can absolutely use a calculator. They're behind Surfing Cat if you want one. Y equals. I'm going to get some more out. Oh, she's going. Awesome. There's at least one calculator per table now. What is negative 3,246 divided by negative 2?
76,361.
That's not the 3,000. I think you did the other one. Yeah. So yeah, our 1,623x. And then are we going to have a plus or a minus? Plus. And then what did you get, Giovanni?
76,361.
361. Yep. So then we were asked to find our slope. What is our slope? 1,623. What is our y-intercept? So those are the pieces we've done before. It's bigger numbers, but it's the pieces we've done before. The tricksy thing on this one is the putting it into context. And in that case, we're going to use the words we have over here. X is the number of years since 2010. And Y is the revenue in millions. So our y-intercept, think about what that tells us. Our y-intercept gives us the revenue, because that's a y thing. We definitely know that. That is not how I write an E. Come on now. Revenue when what? What about a y-intercept do we know? We think about my y-intercept. I know my y-intercept is at 76,000, somewhere way up here. 76,361. What do I know about the x for my y-intercept? What's the x value of that point? If it's on this y-axis, what's the x value? 0. So it is the revenue when 0 years since 2010. And I know that's an awkward way to word it, but it's a way to pull our actual words from the paragraph and not have to re-grammarize it. Because grammar is a construct. I don't care about the structure. It's our revenue in millions of dollars when 0 is the number of years since 2010. Or you can say it's the revenue in 2010. Would be a more Englishy way to think it. With slope, how do we move with our slopes? Like in general, not in terms of this problem. How do I move with a slope? rise over run, right? Our rise has to do with the y's, and our run has to do with the x's, right? So what it is called is when it's called the change in y's, and my y's are all about revenue, or change in money, per what is my x is about? Yeah, per years. So it's the change in money per year. Or per years. So it's the change in revenue, change in money per year. Okay, we're going to think more about that slope and how we did the change in y's and the change in x's, because what we're going to start doing next is we're going to find the slope from 2 points. Let's see. So we've talked about slope for a little while. Our slope is our rise over run. So the way we're going to calculate this when we're thinking about 2 points, what we usually do is we think about point 1. So we'll say it's x1 and y1. And point number 2, x2, y2. And the way we calculate our slope, it's the change in y's over the change in x's. So we're going to take one of our points. It genuinely does not matter which one. Traditionally, we write this with y2 in front because usually it's bigger. Minus y1 over x2 minus x1. So it's the change in y's over the change in x's. If you get into physics here or ever, you'll see it as delta y over delta x. It's the change. The triangle means change. So when we're looking at 2 points, we're going to take the y. So we're going to take the y, and we're going to subtract them. And then we're going to take the x, and we're going to subtract them. It does not matter which point you put first. What does matter is that we have the same point in front and the same point in back, top and bottom. You cannot flip it ever. Otherwise, you're going to be playing games with your signs. And we're going to practice this. So if I give you 2 points, so we have 1, 2, and 3, 8. What we're going to do is, I'm going to real quick change that color so it actually shows up as a different color. We are going to find the slope between these 2 points. So what we're going to do is we're going to call this point 1. This is x1. Sorry, I got to zoom in here because I can't zoom in. We're going to call this one x1, and we're going to call this guy y1 because it's my x and y's for my first point. We're going to call this one x2. We're going to call this one y2. It's the x's and y's. And what we're going to do is we're going to put them up here. So I'm going to take that fraction to find my slope. And we're going to take my y's, my 8, and I'm going to subtract 2. In the denominator, I'm going to take my 3, and I'm going to subtract 1. I have my blue point together. I have my purple point together. It does not matter which one's in front. I'm putting this one in front right now. But it doesn't really matter. And then we're going to simplify this. 8 minus 2 is what? 3 minus 1 is what? 6 over 2 simplifies down to be what? 3. So our slope is going to be 3. This is a formula to find the slope from 2 points. We're going to practice this again. And I'm just going to give us a new page to write on. M equals, you should still have this on your page. Y2 minus Y1, X2 minus X1. So I'm going to give us 2 points again. We're going to have -1, 0, and we're going to have 5, -2. Again, it genuinely does not matter which point you call 1, which point you call 2. It does not matter. I just tend to go left to right. X1, Y1, X2, Y2. That's all the little numbers mean. It's just labeling it for point 1 and point 2. So what we're going to do is we're going to build this to get our slope. Slope is the fraction that has my y's on the top, -2 minus 0. Y's on the bottom, 5 minus -1. And we're going to simplify it. -2 minus 0 gives us what? -2. 5 minus -1. What do we get? 6. Minus negative. The double negative becomes a plus. So this becomes 6. -2 over 6. Does that simplify down? To what? -1/3. Okay. Tomorrow, we're going to start taking the 2 points like this and play with it and find equations for the whole thing. Oh, we'll talk about that tomorrow. Okay, I know we talked all the way to the end yesterday, so I don't want to talk all the way to the end today, so that you have time to work and ask questions and stuff, because I hate doing that, which is one of those things. So I am going to pass out 2-3. It is not due until Monday. We're going to talk about it today and tomorrow and Friday. Okay? So that is not what I intended today. That is not a weird day. Okay, what else? All right. We are going to be working on Alex on Friday this week, but it's just one of those things. I don't know why it's on today's thing. Today is Wednesday. Ooh. But I'm going to pass out 2-3. So there's going to be stuff on here we haven't talked about yet. The front side is all our slope-intercept stuff. The back side is what we're going to be doing over the next couple of days. It does have 2 where you can find the slope from 2 lines. Or slope from 2 points. Okay? I still have the tutu homework due tomorrow because I know it's long and those absolute values can get real long, so I didn't want you guys to have to rush through it. If you've got it done, you can turn it in early. Like, that's always absolutely fine. But I also know sometimes those problems get real long, and I want you guys to have people work on it next week.